Hey guys, this should hopefully, fingers crossed, if I can get it done in the time I have left, be our last video for the 5.6 section. So sorry to break it into so many videos, but it's kind of a big topic. So here we're going to talk about the average rate of change when it pertains to polar coordinates or polar graphing. So you're going to see this same formula we had earlier in the year. This is not new. This is something we did use earlier to calculate the rate of change. And honestly, it's just they give you values over this certain interval, A and B, and then you plug those values into the function, see what the f of A and the f of B would be, and then you just plug it into this. So that is how we've done stuff in the past, and it's how we're going to do stuff here as well. Okay. All right. So we're going to plug in our values. What you see here is our little interval where they are giving us the A and the B value. Okay. So they can also put this in the other notation as well. I've seen this one. Again, that would be A and that would be B. So either notation is fine. The person who makes these, I think he prefers this one or something, but I've heard that either notation is fine. Okay, so we're going to use that formula, but in order to do so, maybe I have the A and the B, but I do not have the f of A and the f of B. So we're going to figure those out, okay? So f of A, that would be me plugging into this formula, 3 minus 3 cosine of my A value, pi over 2, okay? So maybe I should have plugged that in there. But yeah, so we're plugging in the A value where theta goes. Then just clean it up. 3 minus 3, cosine of pi over 2. You got to think of where pi over 2 is. And what is cosine? It is 0. 3 minus 3 times 0 should just get 3. Okay, let's do same thing, but with B. So f of B, I'll do it this way. F of pi is what we're really doing. 3 minus 3 cosine of pi. All right, cosine of pi. You look at pi on your unit circle. The x-coordinate there is -1. So there we get our value. 3 minus 3 times -1, same as 3 plus 3, which is 6. So we have our A, we have our B, we have our f of A, we have our f of B. We should be set to plug this stuff into the formula, okay? All right, so my formula for the average rate of change, you can see that up here on the top of the screen, so I'm not going to rewrite it. But the way that we plug these in is we want f of B minus f of A. So 6 minus 3 over B minus A, pi minus pi over 2. 6 minus 3 is 3 over pi minus pi over 2. Pi minus pi over 2 is still pi over 2. You can't leave your answer like this, guys. You got 3 divided by pi over 2. So I've got to do multiply by the reciprocal, or for those of y'all who love your keep, change, flip wording, you can use that. Multiply across the top. 3 times 2 is 6 over pi. That's our average rate of change. Okay? That one I feel like is pretty simple. It's just plugging things into a formula, getting an answer, straightforward, okay? Remember that this formula comes from your slope formula, the thing that was like y2 minus y1 over x2 minus x1. It's your outputs you're subtracting in the numerator, the inputs you're subtracting in the denominator. So you just make sure that you are keeping that in order, okay? All right. Let's go to the next page. Oh my goodness, we see a rose. All right, on this rose, they said the figure shows the graph of a polar function. And they gave me an equation and the interval in the polar coordinate system. On which of the following intervals is the average rate of change equal to 0? Okay, so you have one of two options. You can either do what we did on the last page 4 times or until you find the thing that comes out as 0. So where you have your A and your B, plug these in, get f of a, plug in, get f of b, and then figure out the rate of change and see if it's 0. You can totally do that, but you would be doing a lot of those things over and over and over. So it kind of depends on you. The alternative method is that you could look at this as a rectangular sine function instead. So you have two options. Okay, so I'm going to say right here, just so that you have that in your notes. Either use the formula on all four, or graph the rectangular equivalent. Okay, so do you. Okay, I will show you the graphing one just real quick, and then I can show you. It's so time consuming. I'll show you the graphing one, and then we'll see. Maybe show you the other one. We'll just see. Okay, so this is supposed to be the graph 3 sine 2 theta. So keep in mind that our period has been changed. The period of your function, remember that's 2 pi over b. B happens to be 2 here, so 2 pi over 2 is just pi. So we know that. I see the amplitude is 3. It has not been shifted up or down, so keep that at least as a piece of good news. So we're going to say that this goes out to pi. Again, put all of your little interval breaks in here, 3 pi over 4. And you can always include more than that, but I'm going to just do that for now. Because this thing has been stretched by 3, we're going to make our y-axis go up and down 3. And then we should be good to go ahead and graph this. So sine starts at the origin, and then it's going to go up. Unless it had been flipped, that's a pretty straightforward thing to sketch a graph of, okay? So here's what I want you to look for. If they want the average rate of change to be 0, you're looking at, but from, like if I look from pi over 4 to 3 pi over 4, those first two choices, from pi over 4 to 3 pi over 4, do you see where those points are? One is up high, one is down low. They are not at the same y value. So if they're not the same y value, it doesn't work. You look at 3 pi over 4 to 5 pi over 4. 3 pi over 4 is here. Now they had assumed that I had drawn this further, so I probably should, just because they did say over that interval. Okay. And then 4, 2 pi, 3 pi over 2. Here we have 5 pi over 4, 7 pi over 4. And you get the same pattern that continues. So you can just sketch that real fast. Okay? So if we said from 3 pi over 4 to 5 pi over 4, I want you to look at these values. Again, their y values are not the same, so they cannot have the same rate of change. Right? Look here, 3 pi over 4 to 7 pi over 4. All right. 3 pi over 4 here to 7 pi over 4. Do you see how they both are at the same level? If I were to draw a line through those 2 points, it would be a horizontal line, which has a slope of 0. They asked which one has an average rate of change equal to 0. It would be this one, because they have the same y coordinate, they have the same y value. Therefore, if you plugged it in the formula, it would give you 0, because that's how it would work out. On this next one, we have pi over 4 to 7 pi over 4. So pi over 4, 7 pi over 4, up high, down low. That's not it. Okay? Okay, for time's sake, I'm just going to say the other one you could do is just use the formula, plug it in for the f of a, f of b, plug it in, see which one came out as 0. So you can do you. All right, we got another example here. All right. This one says we want to, in the polar coordinate system, we've got this graph. On the interval theta, blah, 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 no holes. Okay, here we go. It says the graph passes through the labeled points A, B, C, D in that order. A, B, C, D in that order. Which of the following intervals is the average rate of change of R with respect to theta the least? So I want you to look at this. From A to B, if you were to draw a rate of change between those two, they have the same output, right? They have the same R value. So I want you to think about the fact that if they both have the same R value, then that means that their average rate of change is 0 because they had the same outputs. Look from B to C, okay? From B to C, that increased. R increases. Okay, so the AROC is going to be positive because R increased. Okay, you look at the next one. They said from C to D, the R value is the same. So the average rate of change is 0. And then from D to A, the R value got smaller. So it's going to be, the rate of change would be negative because it got smaller. All right. So because R decreased there, that has to be our answer because that's going to have the smallest rate of change. It'll be negative. Okay, let me look at the next one. Okay, let's see if we can knock this out real fast. Okay, so I got 7 minutes left. All right. So this last bit, estimating values of R using the average rate of change. Essentially, I know they're trying to bring point slope formula back into this. And then what they did is they said, okay, well, if we're dealing with this stuff in polar form, well, number one, the average rate of change, that's the slope. So it's like they've replaced that with slope. The other thing is that they've moved this y1 equivalent value to the other side. So they've added it over. This is plus m times x minus x1. And then they decided that they were going to turn that into these coordinates. Now I want you to think y is the same thing as f of x, or in these circumstances, we'd be looking at f of theta. Okay, so that is an equivalent piece, right? Slope is the average rate of change. And then over here, x minus x1. Now remember, thetas are the inputs for your polar. So theta minus theta 1, equivalent. It's just uglier looking because it's in that polar format and because they just wrote the average rate of change fully out instead of just saying slope. And that's fair. They can do that. The question that we have below is they want us to approximate where 5 pi over 6, like what the output would be. And they gave us these values here. So what we do is we have theta and f of theta. We have an A and a B. We have an f of A and we have an f of B for all of that. Okay. You can also consider this to be like 0.1 and 0.2, if that helps. Okay. So when you go to plug these things into that formula from up top, I'm going to try to keep it visible for just a moment while I get it set up. Then I'm just going to get a generalized equation here. Okay, so, and honestly, if you prefer to get the slope separately, you could totally get the slope separately and then plug it in. But just because they gave us this full equation, I'll try to write it all the way out. All right, f of theta 1, we're looking at f of theta for that first point. That's here at this 2. So we'll have 2. We're going to have plus, and then we've got to use our formula. We want f of b minus f of a, so negative 1 minus 2 over b minus a, 7 pi over 6 minus pi over 6. Then that's going to get multiplied by theta minus our theta from our first point. Okay, so I've just plugged in values to that formula where they go. And I know that looks messy, but we got to get an equation. So I'm going to just take a moment to clean this up. Negative 3 over 7 pi over 6 minus pi over 6 makes 6 pi over 6, which is just pi. This is theta minus pi over 6. Again, 2, oops, We're going to make this be minus 3 over pi. And then this is theta minus pi over 6. So this is an equation that you could use to plug stuff into. Now, remember what they had said is they want us to approximate what 5 pi over 6 would be. We're going to plug that in, okay? So we're going to take f of 5 pi over 6, and we're going to plug in that theta value. Over here, 5 pi over 6 minus 5 pi over 6 is 4 pi over 6. All right, we can clean this up a little bit. The pi's are going to cancel out. You can even cancel between like the 4 and the 6 if you want to, because 2 goes into both of those. You could even cancel across this 3. This 3 would cancel with that 3. So really this is minus 2. And so we would end up with 2 minus 2, 0 for our output. All right, guys, that is it for 5.6. And just, if you need to go back and watch parts again, please go do that. Thank you for your patience, and I will see you guys next time. Bye.